Welcome to MyProjectBazaar.com. Our product title is Steady State Stability of Current Mode Active Clamp ZVS DC to DC Converters. Now we are going to discuss about our product abstract. Active clamp DC to DC converters are pulse width modulated converters having two switching featuring 0 voltage switching at frequencies beyond 100 kHz. Generalized equalized circuits valued for steady state and dynamic performance have been proposed for family of active clamp converters. The active clamp converters is analyzed for its dynamic behavior under current control in this paper. The steady state stability analysis is presented on account of losses damping inherent in active clamp converters. It appears that the stability region in the current controlled active clamp converters get extended for durations a little greater than zero point 0.5, unlike in the conventional Howard switching converters. The conventional graphical approach fails due to the coupling between the filter's inductor current and resistant and inductor currents, an analysis that takes into account the presence of resonant elements in the presented to establish the condition of stability. This method correctly predicts the stability of current control active clamp converters. A simple expressions for the maximum duty cycle for subharmonics free operation is obtained. A converter's circuit proposed to reset the flux in the isolation transformer of a flyback converters developed into a new family of soft transition converters. Such converters are named active clamp converters. The analysis of active clamp converters have been presented with different topologies and different levels of approximation. Now we are going to discuss about the running procedure. So our product is developed by MATLAB simulation. The MATLAB simulation, the simulating tool. This tool we are going to develop the product, the DC to DC converter model. In the DC to DC converter model is giving the input is 68 to 78 voltage, and then we will get the output for 8 to 12 voltage, maximum 15 voltage. So it is the main is buck converters using these blocks, and then the main controller, the PWM, pulse width modulation, is the main controllers. We are using the controllers, and then active clamp converters, its main steady state analysis. The softest transition active clamp converters combine low switching loss characteristics of resonance converters with constant frequency characteristics. The conventional PWM converters, they are essentially square wave converters for the most part except during the resonant transition. The active clamp converters having advantage of constant frequency PWM communication ZVS and low voltage stress due to clamping action. The switching transition of main switching of lossless, whereas the turn off transition of auxiliary switch is loss. ZVS back converters with active clamp. The main active switch S1 is turned on T is equal to 0, following the slope of the voltage turn on and off conditions. The ZVS converters with the active clamp retains the simple features of the hot switched components. In addition, ZVS converters with active clamp exist lossless clamping the dump in the dynamic performance. This may be seen by the presence of lossless resistance in the equivalent circuits, the damping resistance in the functions, resonance inductor, the switching periods. In converters where the damping is quite the substance, the nature of frequencies of the output filters and real closed loop component is easier is designed. It's worth checking if the damping leads a better performance these converters under current control. This is our input and output voltage of the simulation output screenshot. We are giving the input 68 voltage DC, and we get the output 11.5 voltage DC in output. Now we are going to discuss about our product flow diagram. And this is our flow diagram. This is a source. So what we are giving the input voltage. So first we are giving the DC voltage. For example, we are giving 68 to 72 voltage DC voltage. And then converters. What type of converters we are using? We are using buck converters. Buck converters means the reduce the input voltage to output voltage. So for example, we are giving the input voltage 68, and buck the converters, it will be give the output voltage 8 volt to 12 voltage. So this is a buck converter process. And then we are using PWM, pulse width modulation. This is a controller. And then ZVS inductor. The ZVS converters with active clamp retains the simple features of hot switched. In addition, ZVS converters with active clamp lossless tap in the dynamic performance. They may be seen the presence of lossless resistance in the equivalent circuits. So we are using the load. So what type of load we have getting? So how will we reduce the voltage and get the output voltage? So some resistance value we are giving the output load.